Yeah. Hello, everyone. Good morning, good afternoon, good evening, and namaste here from India. Um, Thank you for joining the session on teaching and learning STEM in the new age. And yeah, we have our amazing panelists here, um, and we are going to have some great discussions. Amanda, if you can move the slides. Yeah. If you haven't gotten a chance to rename yourselves, please do so. And in case of any code of conduct reporting, please report it to either myself or anyone with a red background. That works as well. Great. And here are some, you know, this is the drill. Here are some links that have been floating around during the Bio Summit for you to have a better experience. Great. Next slide. And as Aruna was speaking, thanks to our sponsors. Yeah, it's been a great first day with Bio Summit. Yeah, next please. Yeah, I really wanted to take a minute to thank the session support team here. These people have been really amazing and keeping the energy up despite being middle of the night for some of them. And yeah, I think Justice's photo is missing out from here, but he has been throughout all the sessions of learning and ed track, and I'm so happy to have this session support team with me. Awesome. We can move on. Yeah. Okay. So briefly going how the session is sort of structured is our panelists are going to present for like 3 minutes each. They are going to introduce themselves, their work setting, and then we will move on to the panel. During the presentation, during their present section, they will also talk about they will also talk about one question that was sort of, the opening question for this session, and then we'll move on to the panel. And in the ponder section, we basically will have Q&A from the audience or from the panelists. And yeah, that's more that's almost cool. So the presentations are in the order of the photos mentioned here, and we can get started with Amanda if that's okay with her.
Awesome. Thank you, Shrestha. So excited to be here for the APAC session. My name is Amanda Strawhacker. I am a researcher and faculty member at Tufts University, where I work at the early childhood technology program. It's basically a teacher training program for bringing technology and robotics and STEM and biology into very early childhood. So K through second grade, or maybe 5 to 9 years old, 5 to 8 years old. I work with a DevTech research group where basically I spend all my time thinking about the big questions of STEM, what's cutting edge, what's new, not really because we care so much about new stuff, but because we know that especially when things are new, no one's thought about how to introduce it to young kids, and they're usually the first people to experience it on the ground as well. So I think about tools, picture books, and curricula for introducing kids to topics that are typically not introduced until college or later, because a lot of people assume that they can't understand it. And a lot of my research and the research of my colleagues has shown that that is an erroneous misconception. So you can go ahead and change to the next slide. So I'm just going to share about 2 projects that I think are kind of relevant for this community. One I actually spent my dissertation working on is Crispy. So it's a tangible technology with an accompanying curriculum and a picture book and stuffed animals. So it feels very much like something you'd see in an early childhood learning setting, at least where I'm based in the East Coast of the US. But the content's very different. So coding is actually kind of a very big topic, computer programming in early childhood here. So we likened coding to DNA and how DNA is like a coding language, and introduced that concept to children. They're actually were able to grasp it and use that idea to code, for example, colors of their bioluminescent stuffed animals. Another project that might be of interest. So the Yville.net virtual world is popular here among especially middle school girls. We're using it. I'm working with a team at University of Pennsylvania, actually. Yasmin Kafai is one of the keynotes of the conference. She is developing a really cool epidemic, a virtual epidemic that impacts the avatars in the game. So it sort of teaches the kids about epidemiology and gets them thinking about virology. So those are just two projects. You can go to the next slide if we even have time for it. But basically the very high level goals, I think, for this age group, for young kids, it's just to get them thinking about science and feeling like they're welcome in this space. And for middle years, so maybe age 9 to 13, really important to get them thinking about bioethics. It's the right age for it, and it's important to talk about it at any age. So, and there you have it.
Thank you so much for sharing that, Amanda. We can move on to the next slide, and Bushra's up next, I guess. Yeah. Bushra, you're muted.
Yeah. All right, cool. Hi, everyone. Good morning, good evening, wherever you are. My name is Bushra. I am based in Dhaka, Bangladesh, and I am the co-founder of an organization which is called Wizkit. Through this, I have the opportunity to be an educator and engage in community biology in areas, mostly impoverished areas. And what I mostly also do is that I am a product developer as well as a microbiologist. And the product development that I work in is basically mostly health tech. And I also do a lot of community engagement with that. And how we do that is we use this community engagement as a leeway for children who we work with to enter into the product development field and sort of gain a work experience with us. So yeah, that's how we basically enable a lot of people who might be opting out from that education track altogether to sort of have that option to gain that experience and to learn a lot of STEM-based curriculums that they wouldn't have had to in the first place. So if we can move on to the next slide, please. Thank you. And so basically, so what we do is we introduce curriculums that are more hands-on for children who are 14 to 20 years old of age. So mostly middle school and high school kids. And these curriculums are basically used to teach them about all the hands-on things in the world. For example, robotics and, for example, design. So what they can do afterwards is that they have the option to stay on as an intern or as a researcher to do a lot of product development with us. So it just helps them to gain that experience because the background of children that we usually work with are from the areas where they don't get the option to do that. If we can move on to the next slide, please. And as a result, what we have done basically is that a lot of times we have had active response in terms of the pandemic when it started, and it has improved the community in a lot of sense where we have been able to come up with products and we have been able to help a lot of people throughout the process. So thank you very much for this opportunity. I hope to talk to you guys again in the panel. Thanks.
Awesome. We just covered a good range of young learners from Amanda to Bushra. Yeah, Christine, take it away from here.
Hello, my name is Christine Marizzi. I'm calling in from New York City. So I'm Austrian native and a trained geneticist and a bioartist. And I moved to America I think close to 10 years ago. And since then I joined several labs to actually build mobile infrastructures. So I'm part of Biobus, that's the community lab in New York City. We have 2 buses, one 1974 transit bus from San Francisco, refurbished microscopes. We have a rolling scanning electron microscope in there. And the other one is an Airstream. So we actually bring these facilities to anywhere where people actually want to experience science. And what I don't have in this picture is actually, we have biobases. It's called the Harlem Biobase. It's a community research lab where we invite the community to actually come over and do some research. And so the audience is actually pre-K, from kindergarten to K-12, high school, and then a little bit college. And I also do a lot of teacher training. So whatever the community wants to learn about science, we just really try to make it happen. And can you move on to the next slide, please? Okay, so because the bus is not going out yet during COVID-19, of course, and we actually actively chose to discontinue in-person programs before we actually went under lockdown in New York City. So we are a group of scientists. We actually followed the current developments and made a decision, okay, we're not gonna do this anymore. We're gonna be a role model. So for the first time, we actually offered a lot of hands-on and minds-on programs directly in everybody's like homes. And we build a public facing website. And what you can do right now is if you go to biobus.org, you actually have Discover at Home, like live stream. So we bring scientists straight into the living room. We have student town halls where students actually sending questions. We find scientists around the topic and they're just gonna answer the questions of the community, like either live in the chat, or you do this in YouTube Live, or the students can actually just send in questions. We have a lot of virtual internships, so everything that actually happened in the lab was continued like online, and we pivoted to science education. And we built a resource library just to really make sure people actually understand everything that's happening right now. And we built a science game going viral where people can learn about infectious disease. And we also have a lot of like very easy and understandable science content online. It's called the Biobus. And next slide, please. So these are our main streams. Like we really thought about what can students do with materials they actually have at hand. So we launched a series of more than, I think now 15 weeks of weekly science challenges, which can be do either inside or outside with like, very easy materials and means. The student town halls I mentioned, and it's really like science based on what the community wants to know. We actually started something around science and racism in society, which is very unusual for us because we have been traditionally been not really tackling with like social sciences, but this is very dear to our heart. So we actually made these series about science and racism in society. And I just want to say the last one is actually, it's the first community science that actually ties in the community about urban viral surveillance in New York City, and I'm a PI of this project. So I'm actually got funding to do some basic viral, urban influenza viral surveillance in New York City, and I'm really looking forward to this one. I'm doing this because I felt a lot of students felt powerless and left out of the conversation during COVID-19. So it's a way of them actually to learn about science and get educated, but also like maybe be potential PIs in the future.
Awesome. I love the fact that you guys had to stop Biobus, even though it, even though it affected your operations, just to be role models for the kids. Thank you so much, Christine. Mayank can take it from here.
Yeah. Hi, everyone. Good morning, good evening. So I'm the co-founder of SrishTaara, which is a library makerspace in my university. And my work is based out of Pilani, which is actually a rural town in India with a population of around 50,000 people, and out of which 10,000 are actually students. So yeah, and I'm an undergrad. I'm an undergrad engineer. I recently graduated actually in a couple of months back. So the primary aim of this project was to work with university students and to understand like what is the divide between theoretical education and how to get that to how to convert that into really practical practical application. So in the photos, like you can see that we started with a 3D printer. It was just four of us, four of my friends. We started with getting a 3D printer. And in the second photo, we have the librarian with us who was very supportive of our work. And he really understood what was going on in the university, as in people did not, like we had around 10,000 students, but not a lot of them really visited the library. I think that was primarily because people have this notion of the library as being very theoretical, and he really wanted to change that image, at least in India. So that is why he started to work on this and establish this space exactly in the library, so that the message really comes out very well that books and practical application have to go hand in hand. And in the last image, you could actually see that where we are currently, we are actually expanding from a 3D printer to a multiple space. And could you go to the next slide, please? So in this slide, I can really get you through the resources that we are actually giving in our space. So one is of course the 3D printer, and the second one is hands-on electronic equipment, like if you know about Arduino or Raspberry Pis. And in the third image, you could see some of our team members taking workshops on 3D printing. So it's surprising to me that being in an engineering college, not a lot of students knew about what 3D printer was at the time that we brought this. And it was hardly 2 years back, I think. So that was really interesting to me, and that really showed me that what we were doing is actually very useful and very needed right now, because you cannot really be in an engineering college and not know about the recent developments that are taking place in the tech. In the last image, there's a computer, high performance computing. So we also, there's another thing that we know, that computing is taking up at a very high pace right now. So it's very important to be updated with what's going on in the industry right now. Could you go to the next slide, please? So like I said, the primary motive of establishing this space in a library was to bridge the gap between theoretical education and practical application. So that metaphor really comes out, right? And really we are making accessible all the resources, and these are very expensive resources, so to say. Like not every undergrad can afford these resources. So I think that also makes sense to make these resources accessible and to really get these to university students so that they can use it without really going through that arduous procedure of getting a lot of permissions from the professors and really trying to convince the professors that their idea is really creative. I'm not saying that the professors are not supportive, but I'm just saying that it takes a lot of time and it may act as an inhibitor for a student which really just wants to come into a space and just wants to try some things out. So, and it was also surprising that we are doing this at an undergrad level, not even at a school level. So engineering undergrads at least are supposed to know all of this, but in my experience, I've found that that's not really the case, and even more so because our college is one of the most revered colleges in engineering domain in our country. So really, and like you could say that we are trying to help people from going from thinker based environment to a tinkerer based environment where they don't just think and let go of that idea. They actually use that to make something creative, and maybe not even something creative, just something that they want to. So that really promotes them to work on it further. Like I've heard this saying that if you can handle one idea, you can handle many as well. So it just starts with one action. So yeah, that would be it. Thank you.
Awesome. Thank you so much. I really love that metaphor. Think from thinkers to
Yeah,
tinkerers.
thinkers to
Great.
tinkerers. Yeah.
I would like to add one of the features that I really loved for your SrishTaara's logo is the fact that I think you can also sort of chime in on that. The fact that the radial symmetry thing. Could you explain that?
Right. So if you look closely in the logo, the nodes are not really radially symmetric, and that was actually, so we got a lot of questions when we put this out, that why is it that your logo is not symmetric. So actually this was done on purpose, because we don't think that, so see, the idea is to actually get order out of disorder, right? So you cannot expect something innovative or something creative come out of a very systematic procedure. I mean, of course it has to have a structure, but often we found that innovative ideas come out of disorder. Like if you've seen a lot of the companies, for example, Slack, if you know what Slack is, how it came about. So Slack wasn't meant to be a messaging service. It was actually being used for in a game development company, and it actually came as a byproduct of that company. So we understood that we don't want to make a structure and to tell people how to do things. We want them to just sit casually and just put on their thinking caps and really be very random about what they're thinking, because at the cusp of multiple disciplines, that is where you find really interesting ideas. So that was the motive behind that logo. Yeah.
Thank you so much for sharing that thought, Mayank. So yeah, as we move on from our present section of the session to the panel, let's dive right in with some hard-hitting questions. Awesome. So I was wondering that given we have panelists from such diverse community with such diverse community experiences, and who are chiming in from two different parts of the world, broadly speaking, I was curious if you guys could shed some light on one of the most underlooked pain points in teaching and learning STEAM, in your own context, and why do you think it remains unsolved as of now? We can start with Bushra, if she wants to go ahead.
Right, thank you. I think for me, a lot of times, a lot of the initiatives or a lot of things that we want to take on lacks a lot of funding, and a lot of times from the organization, like we find it problematic because the initiatives that we are usually interested in taking usually lacks a lot of sort of monetization, in terms of the fact that, when we're approaching someone with the idea, or when we're trying to partner up with institutions, or when we're trying to sort of come into collaborations, usually people don't really see the more intrinsic value of it. Rather, what more recurring problem on this end here is that they usually see the profit end of it. So in my head, it's something like, it's something that's really valuable in terms of teaching. It's a value that we're incorporating within children. But then a lot of times when we're asking for these fundings, a lot of times we have to sort of face that rejection, because people really don't see anything other than the more profit-oriented end of it. So I think in terms of as an educator, as an initiator, through projects, I have had to face a lot of rejections where, sometimes it's been heartbreaking, but sometimes I've also sort of been able to use that to sort of pivot onto other more better stuff. But I think rejection has always been a constant, sometimes it's been good, sometimes it's been bad. And, but it's something that I think as educators and teachers, especially in the South Asian region, we've always had to constantly face. Thanks.
Yeah, that's a great insight. Even Andy chimes in that, funding doesn't always matches the needs of education, which is so true. If Christine, if you want to chime in right here and explain what are the pain points from your context?
Yeah, I mean, I just want to add on to what Bushra just said, like explaining, from a business model, like what's the return of interest of education, and that's like, what science communication and real good science outreach is like, there's always still going to be an ask, what's the return of interest for this, and then and a lot of people don't understand, a well-informed like community, like, there's just so much improvement change can really happen. And then there's another aspect, if these people move on later on, science outreach and science education can later on also informing policy, like, you probably going to address the Senate later on, or like some kind of your governance. They understand actually the technology behind, certain things, and then they can actually just, base new laws around this. I mean, right in America, we have huge distrust around science, at least for part of society. And then what this is causing right now, and especially in terms of a crisis, is just really mind-blowing. So it's a huge return of interest, empowering youth, empowering people, empowering women to just really understand what's going on with like their life and their body, and then see the life and world with a different lens. So it's, for me, that's like a value that cannot be measured, but still, like, we all have to pay salaries and, rent spaces and buy materials. So we all work into a very small budget, but yeah, that's why the power of community comes in.
Yeah, that's a great point, Christine. I mean, to understand return of investment in this particular case, people have to be a little bit, farsighted. Sorry. Yeah, that's great. Awesome. If Amanda and Mayank, if you guys would like to add some of your pain points, that would be great.
Sure, yeah, I can hop in. So just to reflect on the context I work in, I work with young kids and I work with teachers. So the pain points are kind of maybe scale actually to more broad settings, but there are sort of two that leap to mind. One is the transition from informal to formal spaces. We do such, I at least feel like anecdotally, I see such amazing generative work happening in museums and spaces like Biobus and workshops and maker spaces. And it's so hard to get that happening in a school setting as well, especially by middle grades when standards and curricula are just so slam packed for teachers, and they really are kind of, their hands are tied in terms of how much time they can devote to something new, something that hasn't had a curriculum behind it for 50 years. So that's one pain point is I think that sort of results in generating buy-in at the administration level in schools that a lot of teachers bring to me as their sort of growth area. And then something sort of broader that comes up a lot is, year after year, we continue to see stereotype threat facing really young kids who are internalizing from age 4 and 5 that they're not welcome in STEAM spaces because they don't look like the people who typically wear lab coats on their cartoons or in their picture books. And I mean, it's really hard to change an entire, at this point, globalized societal culture around what is effectively male white supremacy, male white patriarchy. And, it's hard at this point to pinpoint like a way we could change that doesn't sort of result in a massive culture shift. But I think that's pretty much where we're headed now. It's so easy to start with stereotype threat at home. Kids see what mom and dad do who fixes the IKEA furniture and who cooks dinner. Yeah. And that's a great place to just start flipping the script on who is invited into science fields and who is allowed to be an observer of science work.
True. That's such a great point there. Yeah, that's really eye-opening, Amanda. Thank you so much. Mayank, would you like to come in here?
Yeah. So like most of, like as Bushra and Christine talked about funding also. So I think in my case, a lot of our funding comes from the library itself, but this was also a concern for us, that how do we get the space to be really sustainable, as in wherein it can produce what it's consuming, right? So I think one of the things that we tried to do was get people who actually were working on products, so to say, for example, an incubator center. So and we actually had a very good experience with that. A couple of startups came in, used our resources, and it doesn't really consume a lot of time. They just wanted resources as in a 3D printer because it's very expensive and they don't really have a lot of funds for upfront for prototyping the product. So they used all of that and they produced, they made prototypes of the product and they pitched it to investors and they got it funded. This really projects a positive picture. I think in a way this projects a positive picture, and that this helped us pitch our space to the university further to get more funds from that side. So this is one way that we try to handle this. But again, this would be more difficult in a community-wide space where we are targeting students from impoverished backgrounds like Bushra's work. So even I've been thinking about doing that also in my own community. And that is one thing that we could look on. And there's one problem that even we are facing right now. Another problem that I think we are facing is engaging the students themselves. So we know that we understand that this is something that's very, very useful, right? And that students should need this. But it has so happened that culturally, people have lost interest in a maker environment or maker activities. So they've been so focused on the studies right now, and the formal curriculum itself is so hectic that they don't really get time to explore out of that, and they don't see any immediate returns of working hands-on. They understand that if they do well on the studies or well on the courses, they'll eventually get a job, and that's that, and that is the end goal, right? That is what they came here in the college to do. So even if they wanted to explore it beforehand, they wouldn't do it in the college. So how do we engage these students to come and explore stuff and to really show them the long-term picture, as in that this is what real science is, and you should not really be targeting only jobs. So
yeah, that's a great point, Mayank. I completely resonate with the cultural context because I've seen that happening in my institute as well. So that particular point is a great segue to my next question that I have that I was wanting to ask you guys. So from one of the earlier panel discussions that Justice was moderating, Dr. Natalie Kuldell from BioBuilder Foundation said a very nice quote. The greatest resource of wisdom we have is within students themselves. They surprise, delight, and inspire us. But like in my limited knowledge from our part of the world, children are usually not provided the liberty to decide for themselves in things related to education till a very, very, very long time. And I was wondering what you guys felt about how much of an impact does culture have in these kind of mindsets? And yeah, if maybe Amanda, if you would like to chime in on this and highlight the impact of cultural context in STEM
Sure.
ed.
Yeah, I started laughing a little bit because this is not my story, but a dear friend and a colleague of mine shares this story a lot, and it always really makes me think of context for our students. So he worked at a makerspace in Rwanda that was like, I don't think it was created for this, but it ended up serving a lot of refugee population learners. And when he first got there, he was like, okay, how do I draw this in? How do I start making, getting some hype around this with the students? And he decided to do a classic egg drop experiment. I don't know if you guys are familiar when I say that, but in the US, it's a pretty common experiment where you take an egg and everyone gets sort of the same materials and you try to build something that will sustain the egg from a drop. And he ran the whole study or the whole thing with the kids, and he was like, this is amazing. Like, literally no one has broken their eggs. Usually there's at least half the group, if not more. And he was like really impressed by their ingenuity. And at the end, he was really surprised because in the reflection conversation, no one wanted to talk about their designs. The only thing they wanted to ask was who gets to keep the eggs. And that has always stuck with me because, what we bring into a classroom, what we think we're trying to teach, what we think should be the learning goal, if we're not like having deep conversations with kids and families and educators first, if we're not really thinking about where they go home and where they spend their time and live their lives, our agenda doesn't matter because it's not going to come through and it's not going to have the impact that we hope it will. So I hope that anecdote is as impactful for you all as it was for me. I thought that was a good reminder for me when I'm designing a new intervention to really remember the kids and the learners first.
Yeah. Thank you so much for that insight. It makes me think that as people who are interested in curriculum designing, we really need to use a lot of lenses to look at that particular activity that we are designing, or so that we know that things are not going the way we don't want them to. Bushra, would you like to include some points here?
Yeah, thank you. I think problems that I've seen in my community around the curriculum and the work that I do is something very straightforward, but also something that we've been trying to tackle for a while now, is the lack of girls engaging in the kind of work and in the kind of curriculum that we work with. And I think mostly because the cultural context here is that because of the work that we do, they're not, I think the thing that you said about the lab coats, I don't know, I don't remember who said that exactly. I think it was Amanda or someone. But here girls are not, and especially teens, girls in their teens and girls who are, just in their sort of phase, sort of growing up phase, they're not really seen as someone who would be engaging with stuff like this. A lot of times we have to work with circuits because when we're working with our robotics courses, we see a lot of times, because the guardians sometimes are involved with this, they're pulling out their girls sort of from the entire program, from the entire course. And when we try to sort of approach them or consult with them as to what the reason is, they simply say that, I don't really see my daughter as, doing something in this context. But the problem there also is that they sort of want to jump ahead into the future, where they're like, we see our daughters doing this, when they're older, not something when they're younger, because this is, for them as a 15-year-old, as a 14-year-old here, who most of the times might not, a girl who might not have a say in this. A parent usually sees this as, I don't know, sort of a risky engagement, in a sense that just from the outlook of it, just from the sort of idea of it. So I think that's something that's been problematic, just engaging girls in our curriculums, more hands-on curriculums, where they have the option to move on to working on product development with us, because because I am, you know, being a girl and being one of the co-founders of, while working in, you know, sort of, I don't want to call this engineering, but sort of designing products and sort of designing and working with things. I encourage girls to sort of enter into this field, but it's been particularly difficult, especially since COVID, because it just works as a cultural context, you know. Just a fact here in the South Asian community where, you know, we're not supposed to be getting out of the house and we're not supposed to be doing a lot of stuff by ourselves alone. And the more sadder fact being that the pandemic sort of reinforcing this idea, whereas, you know, so a lot of times my co-founders and my friends and I having to sort of fight this idea with the parents directly instead of the children or instead of the girls, even when they are willing to engage or even when they are willing to enroll in a sort of curriculum or course or to work or study with us. So I think that has been particularly frustrating on my end. Thanks.
Yeah, thank you so much, Bushra, for sharing those insights. I think we share similar problems here. I probably cannot speak for the entire Southeast Asian country section of the world, but in India, we definitely face these issues with, you know, there is a set mindset about what girls should be doing and how they should be, you know, what professions they should be pursuing, what is probably not, you know, a very conventional profession to pursue. So yeah, I totally understand that particular point. Moving on, I was also wondering, like, in one of the in I think in the same panel that I was referring to earlier, Brian Brown from Stanford mentioned that, you know, people only retain things that they apply, and I believe that experiential learning is, you know, has been the underlying concept for all of you guys, all of the work that you guys have been doing. But I was curious to know, how do you feel arts education can be integrated into STEM to make it more experiential? So yeah, maybe, you know, Christine or Amanda, one of you can take a shot at this.
Sure, I can go. So, you know, I pointedly use the phrase STEAM instead of STEM when I talk about education and the work that we do with young kids, because a lot of people like to assume, and first of all, I have a bone to pick with arts. A lot of people assume that we mean like the fine arts, you know, painting, drawing, and it's, you know, true that that's a wonderful disciplinary way to sort of incorporate a broader range of folks who might not identify as, you know, STEAM or STEM kids. But I really like a reframing that I've heard Ethan Danahy use, which is, why isn't the A just the liberal arts? I mean, originally when they were thinking about that term, I think it was meant to be more expansive than just painting. So I really think that the civic arts, you know, anything that the liberal arts encompasses is also really relevant and important for STEM. And that, you know, doesn't necessarily have to be an aesthetic element. That seems to be often what it kind of comes down to. And what I dislike about that is that you end up seeing teams of two kids where the girl's decorating a robot that the boy is programming, for example. And that's not the kind of integration that I think the designers of that curriculum were hoping for. So drawing in with art is a great way to start. And the importance of expression and being creative with the work that you're doing is, you know, I'm 100% behind all of that. And I think where it would be amazing to see bioeducation sort of expand is drawing in other forms of artistic expression. So it's not just a tacked on aesthetic design element, it's more baked into the entire scope of the project that you're working on, and thinking of the ethics behind it, and thinking of the consequences of the work, and thinking of the audience and how you perform it for a lay audience, and all of those elements of art that we sort of overlook.
Yeah, yeah. Arts as a functional element in the particular curriculum, rather than an aesthetical element. Yeah, that's a great point, Amanda. Thank you so much. So so the next thing that already Amanda mentioned was something that I wanted to get into was ethics. And ethics has increasingly become an integral part of STEAM education, and rightly so. And in my limited knowledge, ethics education isn't an active concept in primary and middle school education, at least in India. And I would love to know from you guys the risks of downplaying ethics education in STEAM and how that can be brought to the attention of educators where it is downplayed. So maybe, Christine, do you want to take a shot at this?
The risk of downplaying ethics education, I mean, I totally agree. I can't honestly remember. I personally haven't downplayed ethics in my curricula that we have. So I don't think if I can comment much about it. So I just like, I really try to bring ethics in, like in every single thing we do, especially if it's like, student focused and student voice. Students have these like sometimes like naive questions about like, a lot of students care about animal rights or diversity and inclusion, which is like, a segue into like all kind of ethics and biological ethics. It always has been a huge part of my work.
Awesome. Yeah, that's it's nice to know that people like some people already believe that ethics is as integral as the content that we are teaching kids. Yeah, thanks for that insight, Christine. Mayank, have you had any brush with ethical education? I was just curious.
I think in my primary, personally in my primary and secondary school, we did have a course called Moral Sciences, which took us through some ethical values and some morality. But I don't think I've seen it anywhere in science, so to say. And even in a university, how do you really, like, for example, I think Shrestha, what you might be referring to is CRISPR here. Is that the domain that you're targeting when you're talking about ethics?
Yeah, CRISPR is an ongoing example of ethics, but I didn't want to make it very specific because I was wondering if
just to get some context. So yeah, I don't think I don't think that has been integrated into our coursework criteria, but it is definitely one of the things that should be taught in the university as well, because scientists we have this image of scientists wherein they know about what's going to happen if they do something, but they still go ahead and do it. And it's not just scientists, it's also entrepreneurs and engineers, right? So we've seen this with Facebook, that a lot of the co-founders have said that we knew what we were doing was going to have a lot of negative impact on people and children, but we still went ahead and did it. So I think there was a fundamental lack of the larger scale as to what they were doing was going to affect everyone socially, and what was going to be the social impact of it. And if they would have maybe looked before on that aspect, I guess that would have been better. So definitely ethics should be integrated.
Yeah, that's so true. That is exactly the point I was getting to, that although universities do make some effort for ethics education, but it is rather important, at least in my perspective, to have it integrated right from primary and middle school education. And I think that is something Amanda has been working on, if I'm correct. Amanda, would you like to add something here?
Sure. Yeah, we think about ethics in a lot of different ways because we work with such young kids that it comes up often and early. Everything from, thinking of how we're going to talk to families who come from deeply religious backgrounds who might not even agree with the central premise of altering genetics, all the way to helping kids understand that the choices that adults make and the designs that, in the world that surround them, that it maybe hasn't even occurred to them that someone made this table that they're sitting at and the chair and the clothes and, everything in their world is pretty much designed by someone. All of those design decisions have consequences, and those are ethical consequences when you consider, there are numerous examples, right? Racist AIs, tools that are designed for right-handed people. You can think of any bias in the world and there's going to be an ethical consequence for designing for that organization. So Justice is asking in the chat, how young do they begin to understand that? So it's a great question. We didn't expect kids to ask us about ethics. I was working with 5 to 8 year olds for the Crispy project, and we hadn't added any questions about it. It was all focused on, can you understand what we're talking about here when we say that, genes are being altered? And kids came to us and they were like, well, can you tell me why the scientist was doing that? Like, why did they make this animal glow in the first place? What was the good reason for doing that? And that was basically in child speak, give me a justification for this choice that had real consequences for this animal. So the phrasing sounds a little different. We don't use as many long $60 words when we're talking to kids, but the questions are the same. So we bring up ethics when we talk about engineering, and thinking about how when engineers make their choices, we have to think at every step of the way, what's going to be the consequence of this focus or this audience that we're designing for, or this design choice. And it helps them think about ethics too. Their goals are a little different than what adults would be. They're more interested in, for example, helping animals and using bioengineering and biodesign to save ecosystems and help endangered species. They haven't yet learned about, the neo-colonialist complex that's going to result in all of these directions being funneled towards profit, like we've sort of talked about already. So in a way, it's sort of sweet to work with kids when they're not quite, their ethics are a little more wholesome.
That is true. And another fact about working with kids is that they make you feel really old really fast. I have been repeating this over and over again, but it's compellingly feel that, I'm getting older when I'm talking to kids. Awesome. Since we are already into our Q&A, Andy, do you want to highlight some overarching questions that have been in the chat? If not, I still have a bunch of questions to ask.
You should continue with your questions. A lot of people are commenting on some of the really great things that people are talking about. So I think you should continue. You're bringing up great stuff.
Okay, awesome. Great. Thank you so much, Andy. And Arnav, maybe we can unmute people in case they have some questions. They can chime in directly.
Yes,
Okay.
people can unmute themselves.
Awesome, great. I'll go ahead and ask some of the other questions that I was really curious about. So I know that 2020 has been a rather somber year a rather somber setting for most part of the year, and even more stressful for educators and learners, especially when they have been suddenly pushed into a medium of communication that they haven't had time to explore much. Despite that, what do you all think are some of the unique features of digital education that can possibly change teaching and learning processes in STEAM in the near future? So yeah, Bushra, if you would like to take a shot at this, that would be great.
Right. I think some of the possibilities, I think I might be speaking in like extremes here, but I think the entire concept of, physically going to schools might just be sort of outdated by the time, because this pandemic is over. And I personally think like that, because a lot of times I think there's a lot of disenfranchisement that happens within the communities if these schools are closed physically. And I'm strictly speaking in terms of the pandemic context. But I think these are the exact loopholes where, if we're being able to adapt digitally, I mean, is the exact part where, everyone will sort of be able to step into that, level of equilibrium, where a steady or a stable education that's being delivered is being delivered sort of equally within a community, So I think there's a lot of potential to it as soon as, as long as we're being able to overcome the context of being able to equally distribute it within the people who are willing to avail that education. Yeah.
Yeah, thank you. Thank you so much for that insight. Christine, I recall that you mentioned that you guys had to shift your entire operations online with town hall and, engaging students over your website. Would you like to add in some comments that you have about digital ed?
Yeah, we totally had to shift and pivot, going from like serving more than 30,000 students per year to like serving probably all of them virtually, or at least attempting to serve all of them virtually. And so what we did is like, first of all, I mean, we thought of what is Biobus? What does it really mean to be Biobus? And it really means to be there for the community. So what we were all like up late at night and thinking about, okay, how can we really like keep in touch with our community? And then even if you're in New York City and the New York City school system was supposed to give like a lot of digital devices out to students, it simply didn't happen for a long time. So we had a lot of our students that actually could not go online. We went out to purchase for our interns, at least, computers, and we made sure they have Wi-Fi. So the digital divide is real. And we knew there's probably like still thousands of people out there that still can't go online for one reason or the other. We also were aware that students actually have a limited amount of like screen time. Maybe they share the computer with their parents or with their siblings. So these are all real limitations, and we were fortunate we actually could like stay in touch with a lot of people. So very like simple things. But in the end, what made it really like shifted our thinking about what makes like science education real, and what does really matter. Like having a face that speaks to you is like a one-to-one thing over like, pointing a person to another website and figuring stuff out, like, the sense of like having youth around you. We, in our internships, when there was a lot of like protest activity going on in New York City, we converted one of our internship sessions into a space where students should just call in and like speak about the feelings and process emotions, and without even having an adult in a room. And this was probably the most powerful internship session I did this year, because they literally told me I had nobody else that I could speak to you about this. And they were just really grateful. So having a sense of like, even if you just see yourself through a screen of community is really important. Giving them like, hope, okay, things will change, and we give you like, some support, until things change. I think that was the main takeaway. And everything else is extra, of course we provide, science challenges every week. We invite students to just send us questions. We find scientists to actually answer the questions, but like giving them like a weekly highlight they can look forward to is just really valuable, especially in times like this.
Awesome. Yeah, I think digital ed has given a good amount of hope that we will persevere through, and yeah, things will get better. So we will wrap up in like a minute, and I would like to give everyone a 5 minutes break before the next session comes up. So the last question that I had is an actually interesting one, and I would like, tweet length answers from you guys. And if you guys had to pick one fresh fruit to describe the future of education, what would that be and why? I'm sure some of you must have come across this question, but yeah. Amanda, do you want to answer that first?
Yeah, say it one more time. Which fruit? If I had
You
to
just
pick
have to pick one fresh fruit. Yeah, one fresh fruit that describes the future of education. And what and why? And why is your choice that?
Okay. Something leapt to mind, so I'm just going to go with it. I choose pomegranate because it's tough to get into, but there's literal rubies of delicious fruit if you can just make it through the husk. It's worth it. It's worth the fight.
Awesome. That is the fruit we would be looking into future of education. Awesome. Christine, do you want to take a stab?
Actually, I'm going to steal a quote from one of the earlier sessions. I'm going to pick a strawberry because people and students need more than a strawberry DNA extraction. I think that was Dan Pinkerton, and I loved it so much. It's like, yeah, this is the party trick, but we can do so much better. And if you ask the students, what do you want to really do? I want to do a CRISPR stuff or whatever. So I want to paint with bacteria and win the IISER art contest. So it's like, we should move on from this old classic. There's still gold, but there's so much out there.
Awesome. Strawberries it is. Mayank, do you want to pick a fruit for the future of
Uh,
education?
I was just thinking about it. I think I would go with oranges because it's just so segmented, right? So when you get into it, there are these pieces which you can share with your friends. So I think that is the way education should go, wherein you share what you have with everyone else, and that's very metaphorical to me, I think. So oranges would be my choice.
Awesome. Oranges it is. Bushra, you would be ending the session with your fruit.
Right. So I don't know if anyone's ever seen the harvesting of pineapples, but I was actually really lucky to, sort of being able to see the process. But it's actually kind of pretty laborsome and laborious if you sort of think of it. But, at the end of the day, when the fruit is actually being harvested and you're being able to and sort of consume this really nutritious yet sort of really pineapple is a personal favorite of mine, so that's why I think I'll pick this fruit any day. But sort of you're being able to consume this really nutritious yet this really like great tasting fruit. I think education is sort of similar to that. It's a lot of hard work before you get to reap the sort of better bits of it. So yeah, that's definitely going to be my choice of fruit.
Awesome. We just got a new fact that Bushra's favorite fruit is pineapple. In today's parties, we are going to serve virtual pineapples to everyone. Bushra is going to serve them. Awesome. Thank you so much to our wonderful panelists and all the people who have been joining since an hour ago and since a few minutes ago as well. Thank you so much for being here. And we would like to take a group photo, a quick group photo. Arnav, would you be able to do that? So if people want to turn their cameras on, and Arnav can count us down.
We already have a video, right? So yeah, I'll still take a picture.
Yeah, sure.
Are you ready? Are you all ready? Here we go. 3, 2, 1. Done. Yeah, sounds good.
Awesome. Awesome. Thank you so much, Arnav. And we are heading to our next session that is being moderated by Salman here. And yeah, hope to see you guys there. Thank you so much for being here today for this session.